Okay, this is problem 63 from chapter 7. We have this block on a table attached to this spring, and the mass is 1.5 kilograms, and the spring has a force of 1900 Newton meters. The spring is initially compressed by 0.045 meters, and the distance from the floor to the top of the table is 1.2 meters. The question is wondering, what is the speed of the block of ice when it reaches the floor? So when it pushes off here, when it reaches the floor, what's its speed? So we have several equations. So our potential energy on top of the table is going to be equal to 1/2 K delta, our change in x, s squared. Our initial energy, total energy, is our kinetic energy, which is 1/2 mv squared, plus our potential, which is mgh. And our final energy is 1/2 mv squared. So with all of those, we should be able to figure out what our speed is when we are reaching the ground. So first, we're going to set our total, initial energy minus our final energy minus our total initial energy, and we're going to set that equal to 0. Let me write it out. So first we write it like this: 1/2 mv sub 2 squared, which is our final energy, minus 1/2 mv sub 1 squared minus mgh. We set it all equal to 0. But then we can substitute out. We know that our potential energy is equal to this equation up here. So we can substitute that out back into this equation. So we substituted 1/2 K delta x s squared into this equation, and now we just need to solve for the velocity too, because that's our final velocity. And this is just some algebra. So our velocity 2 comes out to v sub 2 equals 2gh plus the square root of k over m delta xs. And then you just plug in your numbers for that. And I won't do that entire thing, but it comes out to 7.01 meters per second is our velocity. That's our velocity when this box is reaching the floor down there once it's pushed off the table.